So, have you been ever working on a project where you do not have a backup of your code and the code is just in your machine and then suddenly your PC just crashes or just lost the files, like you just lost the project? Or have you ever been in a situation whereby you are actually working on a project with a team and then reach a point whereby you want to share files with the rest of the teams, but then you have to use a flash, you have to use share the files with an email, or you use Bluetooth, etc. Or you have been working on a project and then like literally everything is working fine. Then suddenly you make some changes to your code and then everything went wrong. Now, at this point, nothing is working. You wish to revert back to the state where you were before, where everything was actually working fine. But you have forgotten what you are, what you had written for, or even to try Control Z, it is not working because they had probably closed the file or whatever has happened. But you can't actually reach that point. So if you have answered yes to at least one of the questions that I have raised, or you're curious to know how you can actually avoid being in such situations, then this video is actually for you. I am going to introduce you to something known as Git and GitHub. So, what is Git and GitHub? I'll just give a vague explanation here so that you can actually get to understand, so that you can get a glimpse of what this video is all about. But so these are actually tools that you can use to do version control of your code, and it's also useful when you're collaborating on a project with other people. So to actually use Git, we need to download Git. So let's go on to Google and search for GitHub search page like this. If I open it, we need to download this, and then let's go on. You choose any platform that you have, either you're on Mac OS, you're on Windows, or on Linux, you can actually get on your right. Then after downloading it, go on to install it. I'm not going to do that because I already have it, but I'm going to open just a terminal and just make sure that you have it installed. It you just do the version, then you see you actually get a response like this, right? So what do we actually need to do? So I'll give an example here. Let's say I'm working on a project with a group of probably 6 people, right? So obviously what I will be having on my machine and then the other person having on his machine and then the next person will actually be having on their machines are actually two different things. Not actually two different things, but I thought of three, but I hope you actually get what I'm trying to say, but there'll be actually two different, like a lot of code bases, right? Let me just go on to two because I just figured out that I'll be saying two. But anyways, let's say I'm working on a project whereby with my colleague, right? So what I'll be having is the code base on my machine and the code base on the other person's machine. There'll be actually two different. So how can we actually get to work on a project and actually complete it without probably getting into situations whereby we actually have to, let's say, share flash, say files using a flash or whatever, but we can actually have to merge our code and then we can actually work probably with the same files or whatever. So what Git does is it provides version control of your code. So by this I mean we can actually get to, let's say, Git works with something known as a repository. So if we create a repository on Git, then we can actually contribute to that repository. And so if we create a repository with my colleague, right, then we can actually have to contribute, like to push our code to that repository. So if I push my code to that repository, then my colleague can actually get that code from GitHub, right? Then that same code that I have written on my machine, it can actually be on the other person's machine. And the vice versa is also true. The person can actually push the code and then I can actually put the code on my machine, right? So what it does is Git will be on your system, right? So what will be having on your system is known as a local repository, and what will be on GitHub will be a remote repository. So we'll be contributing to a remote repository, but what we have on our machines are actually local repositories. So if I make a change on my machine, I will need to push it GitHub using Git, like that my other colleague can actually pull those codes, pull those changes that I have done on their machine, and we can actually right. So here these repositories actually contains something inside them, so they work with something known as branches. So what branches do is like you can create as many branches as you want. Let's say we are give just to like here, let's say we have a branch for the UI of our system, right? Probably we are saying, okay, I'm working on the UI and the other person is working on the backend, right? So we can actually create a branch probably for the UI only, and then I'll be contributing to that branch. That means the other person is working on it, another branch, which is, let's say, branch 2 or whatever, then they be actually contributing to that branch, right? Then, so whenever I do changes to that branch, then it means the files that I have touched, right, will be changed. And then if I push those files to GitHub, and then if the other colleague pushes his own files that he has changed to GitHub, right, those files, as I've said before, it does what is known as version control, right? It means it would take those changes and push them back. But remember, I've said they are in branches. So there's a kind of special branch which is in GitHub, which is known as the master branch. So you can find it written in some other text as main or master. It's one and the same thing. So we can actually get to merge our code. Say we have this main branch. So main purpose of that main or master branch is to contain up-to-date code on the project, right? It means if you want to give someone to use it, like probably in production, if you say it's an application, we then just have to use the master branch. So it is to contain up-to-date code on the project, right? So we can then actually have to merge our branches into the master branch or into the main branch, which means the files that we have changed, right, will be pushed to the master branch, right, with the changes that we have actually done. That means we have actually collaborated on the project to say, I've written some code, and then the next person has actually written some code, and then we have merged the code together into one. I hope you do understand what I'm trying to say, but it is in GitHub, like you can actually see their power, not theoretically, but practically by actually using them. So let's actually get started by doing something. So I've opened my terminal here, and then let me go desktop. Right. So I need to create a folder on my desktop. Let me just do this, and then let's just say git tutorial. Well, don't just freak out like this is just a terminal. So git tutorial, okay, whatever, need to just do cd, right? So what I've done here is just making a directory like with mkdir. You just make a directory known as github git tutorial, and then I've just changed the directory with using cd into git tutorial. So now I'm now in this folder, right? So what I've done here is just the same as opening your file explorer and then going on to getting that option to say new folder, and then you give the folder the name. Just one and the same thing, right? So what I'm going to do is I'm going to create a local repository on my machine. Then you can actually get to use that. So create a local repository. Let's do git init. You see, initialized empty git repository in this location, right? So by actually doing this, that means every each and every file that comes into this folder will actually get tracked. So if we copy a folder into this file, that folder will actually be tracked. So if we copy a file to this folder, it will actually be tracked, right? So when I'm saying tracked, this means like the changes you make to those files will actually be tracked. If you changed a single, like a single line, then it will actually know that we have changed this single line from this to this. Like it's managing the version of those files, right? So let me actually open a VS Code here. Yes. So what I'm going to do here is I'm actually going to create a file known as what? Let's just do index.php like this, right? So not to say literally index.php. I don't want to write PHP here. Let's just do what? Main.txt like this, right? So what are we actually going to do here? Firstly, let me just type in hello here, and then I will just type in Takuzwa here like this, right? So after doing this, I want to show you something. Let's go on back to our terminal and then do git status like this. You see, we are on branch master, no commits yet, untracked files. This is where we want I want to explain. We have untracked files, which is main.txt, which means we literally didn't tell Git to track this file to say, because this file is actually in our project, right? But we haven't staged it so that it can be actually be committed to say, okay, this was the state that we have, because Git works with commits. So whenever you do changes to your code, right? Let's say you want to implement a certain feature, probably want to implement 3 features. If you implement the first feature, then you need to commit your code. If you the moment you implement the next, you need to commit. The next you implement a final one, you just have to commit like that. You can literally revert back. Probably want to revert back to the point where you were on a second commit, then you can literally revert back. So what do we do so that we can make this file to be actually tracked? Let's do git add. So by adding a file, there are 2 ways to add it. You can actually add just a single file. Let's say we want to main.txt like this. Then we will have staged if the file main.txt such that we will need it to be tracked, right? Ready to be committed, or you can actually use a period like this. So by using a period like this is actually staging every file, not just a single file. Probably we have literally changed 10 files. We cannot just go back to the terminal and write git add, then we choose the file, we go on to say git add and use the file, but you can actually use that period like that. So let's use the period like this, and let's go on to it git status. You see, we now have a different message. Changes to be committed, like here, we have this a new file which is main.txt, right? So now let's go on to a point where we can actually commit to say this is what we have in this file. Let's commit it, and then Git will actually store that state of that file. The moment we changed to another file, we change text, right? In that file, we can actually get to commit again, and then those 2 states will be kept to say, so firstly we had this, and then secondly we had this. If we want to revert back to what we had at first, we can actually do that. So commit our code, we can do git commit -m. So here let's say what is it? You can just say, let's just say initial commit like this. You see, one file changed, three insertions, create mode, whatever, but file is main texting. So if you go on to Git status, you can see we are still on the branch master, but we have nothing to commit, and the working tree is clean. Why? Because we have actually committed, right, our files to say we have this file, right, and this is what we have. So if we hit Git status, that means we have actually commit everything is actually been committed. If it tells us there's nothing to commit, so we haven't done any changes, right? So let's go on to here and say what do we need. We can say hello world here, like this. We go back to our terminal and hit Git status. You can see we now have actually a different message. You can have this file is written modified here, and then hit the main txt, right, that it has been changed. So what do we need? If we need to keep the state of this file, say this is what we had here, like right now, we can actually do it, right, by just committing that, and then we can literally have those two states to be kept, right? So we can, to commit, we firstly need to stage the files for that we want to commit, and then we will have to give a commit message, right? So let's do git add like this, and then git commit -m, and then let's do what, edit main.txt. So what here is actually to say what I've written in this double quotation marks is the commit message, to say let's say we are implementing a messaging feature, and we have actually let's say implemented that. Then we can actually say, okay, messaging feature, like that whenever you want to revert back to the point where you had finished that, then you can actually see that, okay, this was the point. So commit message should actually make sense. There should be not just random messages like you actually think, and tomorrow you have actually forgotten them. So they have actually to make sense. So let's hit this, right? So you can see one file changed. This is the only file that we have. Then if we hit git status, you can see we're still on the branch master, and we have nothing to commit, right? I want to talk about something which is known as branches, right? So you can create as many branches as you want, but these branches can contain different code. Let's say I'm working on a feature, right? To say I'm on a social media application, right? Then I've actually used created the messaging. Let's say I've actually used the chat room, like on WhatsApp. You have opened a chat, right? Then messages are actually being displayed. But let's say I want to, now to make those real time. You see on WhatsApp, if somebody sends a message and you're in that chat, it just appears that message. For example, I haven't done that. That is now what I want to do. Then you can actually branch out from the branch which is the code which is actually working, and then make your changes to that branch. So the changes that you are actually doing in that branch will not affect the changes that you have done when the branch that you have actually branched out from. But whenever you have finished that the new branch that you have actually created, you can actually merge your code from that branch to back to the main branch. That means to say the changes that you have made there actually get to be the branch that you want, and then everything literally gets onto the working. So how can we do that? So let's just do a git check out fnb, and then let's do just do t goes off like this. If we hit this, you see we have switched to a new branch, t goes, right? What is actually happened here? We have actually created a new branch known as Tigos, and then we have actually branched to that. We actually checked out to that branch. That means whatever that will be on the files that you'll be actually seeing in your code will be what is in that branch, right? So I want to do this. better explain it. I want to remove the yellow world like this, and then I want to go back to my terminal with, let's just write git status. You see we are on branch T goes, but what has actually happened in this branch? We have actually modified the main.txt file. Let's just commit this and then git commit fnm. Let's do remove what hello world from main.txt like this. So see what we have done here. We have actually branched out from the branch to say from the main branch, right, to actually the branch Tigos. But we've actually made changes to that file. But remember that file is also again in the branch that we were on our master branch. Let's say we want to go back to the master branch and see which code is actually in the master branch, right? So we can actually do git check out and then master, right? So now we have switched the branch master. I'm not sure you've actually seen what is happened here, but you can actually go on to here where VS Code is actually on. Let me highlight on. So what has actually happened is when I switched to that branch, to the master branch, we didn't have line 4 and 5, but now line 4 and 5 are visible. Why? Because Git is doing what is known as version control of our files. That means when I switch to the branch master, every file, the contents of it were actually the contents that are in that branch. I'm not sure if I actually explained it. Let me repeat it. So whatever that you see in your files is the state of what is on your branch, right? So when you branched out from the branch master, we when we created the branch Tigos, right? Then we actually get to take whatever that was on the branch master and then they're going to be in the branch Tigos. But when we actually changed the file, the state of the file to remove that yellow world, right? You see it was gone. But when you actually checked out to the branch master, then it means we now have what is on the branch master. That is now actually what we get to see, not to say what the changes we have actually made. So that is another useful part of Git and GitHub. That means you can actually make changes to somewhere. You can actually do some experiments with your code, and then literally everything will be working fine if you want to revert back to a state where you actually get things that were actually working, right? So here we've been actually using Git, right, on our local machine, because what we you were using here is that a local repository. Let's say I want to work on a project with other people, right? Then make other people contribute also to that code base, right? So by this we need to use GitHub. Let's go on to GitHub. Just to wait a moment. So let's just create a new repository, right? So let's give this repository a new name to say what? GitHub. So yeah, like this public download. So let's create this repository, right? So here what do we actually need to do, right? So we have literally different options that we can actually use. So we need because create fix it up. So if you have done this kind of thing before or you didn't have, so let's do or choose an option where we have literally not done this kind of thing before. So or you can actually create a new repository from the command line or push an existing repository from command line, right? So what we actually did, we used some features from this, right? But now we need to use some features from this, because what we did was to git init Then we staged our files for commit by using git add, and then we just committed by providing a commit message. Right? So what now? We have a local repository, right, on our machine, but we now need to provide a reference to a remote repository where we can actually keep our code online. That is, to say, kind of a backup, but just a vague explanation. I don't want to confuse, but let's just refer to the word backup. So it means we want to provide a reference to the backup of our code, right? So what do we need to do? We need to provide a remote, right? So let's go on, copy this, and then go back to our terminal and do git remote add origin, and then we provide the link to our remote repository, right? So like this, that means we have actually added a reference to this repository. If we do git remote, if I'm not mistaken, yeah, like that one, then you can actually see that we have this origin. You can actually put a name that you need on here, the origin, but you can actually put another name that you need, because that would be actually the reference to the repository, the name of the reference of the repository. Now, what can we actually do here? What we can actually do here is to push our code, right, to GitHub using. So to push our code to Git, we need to use git push. Or if you want to just push just one branch, or let's hit git push first and see. All right. So the current branch master is no upstream branch. Push the current branch and set the remote as upstream. Use git push set upstream origin master. Okay, let's just do this, right? So what is actually had happened here was to say we didn't have that branch master on the cloud, right? But here we literally had to say just to use git push. We didn't specify which branch that we needed to push. So then I had to check for the master branch, but it didn't find it. So here it's actually going to set it up for us, and then we can actually push. Let's just do git push and see what actually happens, right? So everything is up to date, which means if we literally go on to refresh this page, you can see that we have the branch master here, and then we have a file named main.txt that we actually created there, and the last commit in that branch master, which is added yellow to main text, and we actually did it 10 minutes ago, right? Let's go on, let's push the second branch, which is branch Tigo. So let's do git push you, then this is origin, then let's do like this. Just wait a moment, right? So if we refresh this page, actually see we now have a second branch, like here. We now have a second branch, which is Tigos. So I want to open this file here, then let me open the second branch, which is Tigos, and then open this file again. So you see that this file contains this, and then the same file contains this, but they are in two different branches, right? Let's go on to let's say I want to check like the history of the file, right? So you can see that in this branch, let's go on to default branch, the master branch contains two commits, right? But let's actually create here. You can actually see first commit was the initial commit, second one was added yellow to main text, and you can actually see the time where you actually committed your changes. You go on to click, you can see the commit details. You can actually see showing once changed the file with 3 additions and 0 deletions. Well, let's go on to here. So firstly, we didn't have anything on here, this left side, but here on this right side, you see the changes that we have actually made to file, right? And in this commit, you can see we had these changes. Say when we did our last commit, we actually had these 3 lines here, but then when we made our changes and committed, we happen to have these 5 lines like that. That means Git has actually tracked the changes that we have actually done in our code. You can see that one changed file with 3 additions and 1 deletion. So let's go back here. Let's go onto our main.txt file. And here, when you actually open this file, we can see the history of the file, the history of that single file. So you can see this file was actually made changes to by only 2 commits. But if we go on to let's say like this, let's go on to the branch also open the main.txt, and then let's check the history. You actually see that 3 commits were done. So the moment when we were at this stage, right, when we had this added yellow to main.txt, then we branched out to create another branch. But then we literally made changes to that branch, and then we made a commit again. So you can see in this branch, we literally have 3 commits like this. And we can actually see to say if we are current state of that file, you see we had this, but when we made the changes and then committed, this is now the new state of the file. So you can so by using Git, you can actually see that this was the state of the file that we had, and then at this point in time, we now have this. So if somebody you're working on we are collaborating with someone, and then someone touches a file and then changes are made, probably you would now want to merge those changes to say, okay, I now need this code to be here. Then you can literally see to say, okay, what if actually changed? We were at this, right? But we are now at this. Then you can actually communicate to say probably if something is amiss or if everything is fine, then that is it. You can actually see like, all right. So let's go back to our main like this. Now, we only talked about pushing code to GitHub, right? Now let's say I want to pull the changes. Like someone has literally pushed their code, like I'm working with my colleague, and then my colleague pushes code to GitHub. How can I have that code on my machine? Okay. So what I'm going to do here is I'm actually going to go on to the branch because and then open this main.txt file, and then I want to edit it, right? I want to do this. I want to remove these tags and then do edited file, right? And then commit or update. Let's just say edited file like this, and right. So what I'm actually doing here is to actually mimic what the other person in the is literally do, because I'm just on my machine. So if somebody literally pushes code, right, he has to provide a commit message, then whatever is actually changed, right, then pushes the code to GitHub, and I can actually have push that code, pull that code on my machine, right? So commit directly to equals, right? So if we commit this, and then let's go on here. So let's check which branch are we on. We're on the branch master. Okay, let's check out to branch because the branch that we have actually made changes to it. Check out like this. Okay, now what can I actually do? So what is actually happened here is the files have actually changed remotely. Like another person have actually pushed, right? But what I have on my machine is not what is up to date. So we need to pull those changes. So let's do git pull like this. Let me open VS Code, then open this. Right. So actually see when we are actually git pull, then came back with this file, which is main txt. One file changed, one insertion, and then one deletion, like that one. And we can actually see that our file, which we have on our machine, has actually changed its contents. And we actually have the file here, the text that I added is edited file, right? So there's something that I want to show you. It's like when you which literally happens when you're pushing and pulling code, right? Let's go on back to here and try to do something here, right? Then let me do edited the file. Then here I will do um equals like this, and then provide edit like this. Then let's commit. Let's go on to this and then let's actually change the contents of this file. So to say let me just type in tacos like this. So what is actually happened here? The other person has actually touched the file, right? And then me myself has actually touched the same file, right? But this person has actually pushed the code to the cloud, right? And now I want to make another change to the cloud. What will happen here? Take a moment. What I have on my machine, right, is different from what the other person has on their machine. So when they made changes, right, they made changes with what they had. So if I am actually going to make a change to that file, there is a risk of deleting. If we just saying go on and replace the contents of that file to be what I have actually pushed, right? Then there will be actually a risk of actually missing some parts of the file which were literally crucial, and then everything may end up not working as expected, right? So what do actually happen here? Let's say I want to push, right? So let's do git add and then git commit, right? Then I'll just type in something like here, my mind about the commit message. Now I want to push. Let's do git push ori goes like this. What will happen here? Failed to push some refs to this objects were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same ref. You may want to fix You may want to first integrate the remote changes before pushing again, right? So what do we need to do here? So when this person literally pushed codes to the cloud, right? And then before me, that means whenever I want to push again, I now need to take that same file, put it on my machine, make changes to that file, and then push the file back to the cloud. So take the changes that were literally made by that person, right? We need to do git pull. So let's do git pull like this, right? What has actually happened here? So we have a conflict because this file, I had a file on my machine, right? And then there's actually another file which is on the cloud. Like on my machine, Git knew that we have this kind of state on my machine. And then in the cloud, GitHub knew we have a different state of that same file. So to so actually what I did by git pull was git pull is now taking current state of the file which is on GitHub and merge it with the current state of the file which is on my machine. But then there's now a conflict here because that file is not up to date to say when this person actually pushed, right? Me myself, I haven't actually pushed, but then I had staged the file to say I want to commit it. Then I wanted to push, but I haven't gotten what that person literally had. So a merge conflict actually happens. So all of this kind of conflict when you are pushing, you need to do it manually. Then you need to go onto that file and then choose what you want state of the file to be, and then you can literally stage that file for a commit and then push it to GitHub, right? So if you go onto this file, you can see we have this. So what do we actually need to be on the file, right? So we no longer need this, right? Because this is just a, as you can see, this is the current change that I have on my machine. We literally have this, but then the incoming change which is coming from the cloud is literally this. So let me literally remove what is coming from the cloud. Let's say I now don't want what is coming from the cloud, or if I want what is coming to the what is coming from the cloud, then I can literally remove what I have done before, right? So if I remove this and then remove also this, then we can literally have this, right? Type of state like of this file. Then we can literally go on to git add it's like that, then git commit, then you can say what, let's say it goes like this. And if we push this to the cloud, we should definitely not get what is it, image conflict, right? Say you have some refs that you do not contain some, what is it, that kind of message which comes, let's literally check it, contains work that you do not have locally, right? So you see that we have actually pushed this code to the cloud and then successfully, right? Then if we go on to GitHub on this branch, let's see what actually happened here. This is on branch. Which branch are we on again? Let's do status like this. If you go on to main.txt, you see this is the state that we have in this file, and then this is actually the state that we have in this file, just like that. I hope you actually see the power of Git and GitHub. These are not only commands that you can actually use it, but these are actually probably the basic, and just literally explaining how you can actually use Git and GitHub like that. You can do it, you can avoid sharing files using Bluetooth, email, or actually anything probably with a flash, or you can actually how you can actually collaborate with people on a project, and to avoid the risk of actually losing all your files and you not literally have a backup, or you can actually again reduce the level of risk whereby you actually have a state of code, right? Make changes to the code and then you now want to revert back the state that you literally had, but you cannot no longer do that because you do not have any version control of your code, or cannot actually do a control Z because you've actually closed the file if you opened it again, so literally nothing can happen. You cannot undo, like to say undo closing the file and then undo whatever. Anyways, so with that being said, I'm literally going to wrap up the video here. Let me know what you think down in the comment section. Your feedback is very important. This video was literally helpful to you Don't forget to like the video, share it with someone who can actually get be helped by the video, and hit the subscribe button if I haven't done that, and I'll see you in another YouTube video.